This motor was given to one of Keely's lawyers in the late 1800s. We assume it was given to him, or was part payment or whatever, we don't know exactly. A Mr. Housen. Later on, he donated this to the Franklin Institute in Philadelphia, and it sat in the Franklin Institute for 50 years. And they had a little sign on it that said it was a perpetual motion machine. Well, it was not a perpetual motion machine. They called it that because they didn't know what it was or how it worked, or they didn't have any idea about it. They just called it perpetual motion. And my friend Victor Hansen, who is in the other room, he owns this machine. He bought it from the Franklin Institute for $1,000. Took him 8 years to get the money together to pay for it. He eventually got it and took it home. And he had it since the 40s. So he's had it for another 50 years. 3 or 4 years ago, I had a chance to look at it for the first time. And if any of you are engineers and you look at this thing, you say, it is absolutely bizarre. There's no way this thing can work. Because in conventional male-oriented physics, where we put in energy, we got to hit it with something, you know. This makes no sense because it doesn't operate with that philosophy. It operates with the female forces of implosion. So the thing kind of operates backwards. And when you look at it a little bit and you say, well, this thing operates backwards, and then all of a sudden your mind just gets all clouded and confused because you're not used to thinking in those terms. But after a while it gets kind of simple. And this is brilliant. If Keely did anything, he was a brilliant machinist and a brilliant mechanic. He just had a cleverness of making things. Water would come in through this orifice. Once he got the thing primed with water in the system, he could just kind of give this thing a little crank, and it would create a vacuum, and the water would draw itself through the machine. Now, one interesting concept is the water formed a part of the mechanism. That's not normal physics. That's not normal engineering. We don't normally do that, where the water is actually part of the motion of the machine. So this thing is kind of like a holistic machine. It's not a machine operating on the water or the water operating on the machine. It's the water and the machine operating together as a whole unit. It's kind of like the human body does. So I give this thing a crank. Water will come into here above this level, this tube, this horizontal tube that goes across the front. The tube goes through this pulsating chamber. I call this a pulsating chamber. And the tubes are hollow. There's nothing inside of them. The same thing with this tube. It's just a straight tube. There are holes in the center so that it has access to the internal volume of this pulsating chamber. This chamber is 1/64 of an inch in thickness. It is red brass. It's very hard, very resonant type brass, whereas this is a yellow brass. This is red brass, kind of like a naval brass. And the interesting thing is, once the water came into this and started through the system, this chamber would begin to pulsate. And because it's mostly got air in it, we would have a pulsation of a high and low pressure forming at intervals, very high frequency. So this becomes a pump. Once the water is in motion, this pulsating chamber becomes a pump with no moving parts. It's really ingenious. Just a year ago, I ran across a NASA paper where these guys, some engineer, didn't even have his name on the paper, had designed a waveguide using a transducer, and he had developed a pump using a transducer, there again with no moving parts. So here was a validation from NASA that this concept works. And I thought that was really good that we ran into that paper. In these two mechanisms, one on each side, these are check valves. The water would come across horizontally and start up through this check valve, and all it is a round ball sitting on a round hole. So water could come this way, but it can't go back down. Then the water would come through these pipes around here, there's two on each side, into these pistons. Now, there's two kinds of pistons. This is kind of an enigma why there's two distinct designs on these pistons. They are not the same. In this left side, your right side, we have what we consider a standard piston arrangement. Underneath, we have a bar that goes underneath that pushes a piston up into this larger chamber. The water would come into the top of that cylinder, on top of that piston. And in the end, there's a valve that goes straight through here. It's a rotary valve so it just rotates. In this case, it just rocks back and forth. So the water would come through that cylinder. When the valve got in the right place, the water would shoot through into this cylinder, pushing this crankshaft and causing it to rotate. It's real simple. However, the things that go on while it's doing all of that is really neat. The pulsations would drive the water past the check valves into this cylinder down here, pushing this rod down, which lifted this weight on the far side here. So it would lift this weight on the far side, thereby putting pressure on this water in this cylinder. So here we've got water under tremendous pressure because the injections of the pulsating waves pounding that water. The minute the little rocker arm rocked the valve back and forth, we've got a high velocity stream of water coming past the valve. So when you close the valve on high velocity water, what do you get? You get a water hammer. You get that pounding. And water hammer is when you close the faucet in your sink and the pipes bang in your basement. That's water hammer. There's infinite pressure in that. So that pressure, I did a computer model of what happens in here. And of course, the computer model is based on ideal conditions, which this isn't. But I was surprised that it showed within 8 cycles of this valve opening and closing, the pressure goes to infinity. Now that's an ideal situation, which this isn't. So we got the high speed stream of water coming through the valve system, pushing this piston up, and would cause a little bit of rotation. And on the other side, there's 2 types of water hammer, by the way. There's upstream and downstream. Water coming into a valve, you shut the valve, that water has a momentum that keeps going against the valve. And the reverberation of this shock wave going back upstream, away from the valve, creates a pocket of negative pressure, low pressure, vacuum, which will collapse. There's your implosion, causing a pounding. On the downstream side, the water wants to keep going, so it creates another vacuum, which collapses and causes another shock wave. So if we time that shock wave back and forth on either side of the valve, it goes upstream up the pipe, and then it comes back down. If you open the valve at the same time that reverberation of the shock wave comes back, it will add to the original one. It's like a child on a swing. You push a child on a swing. If you push it at the right moment, it'll get bigger and bigger and bigger and bigger. And by the way, that is the same principle that Moray used in his valve assemblies in the 1930s and 40s, where he caused an oscillation of electrical current. It's much like Bearden talks about today with scalar electromagnetics, where they got bifilar coils, and they got this tremendous charge of current, not current, but potential, that they oscillate back and forth. So we've created a potential in here, and we oscillate it back and forth, and the valve lets loose just enough to keep the mechanism going. On the other side, there is a slightly different, well, it's fundamentally different thing happening. Because this piston down here does not capture water. It is a round ball sitting in a round hole. So when the water squirts through here, it hits on top of this ball and then goes immediately all over the place. But while it does that, it creates a vaporized situation on top of that sphere, and it polarizes the water. Right above the round portion, we have a little chamber in here. It's a little square chamber, and that bothered me for 2 years, what this chamber was all about, because it's a rectangular hole going through this little chamber. That when the ball closes, it closes one end of it, and when the valve closes, the other end of it's closed. And I got to thinking about waveguides and whatnot. This thing is a waveguide. When both the valve and the piston are open, we have a certain fundamental frequency. When one or the other closes, the frequency goes up nearly 4 times. And I think that's in my paper. When that happens, based on the dimensions of this waveguide, we have microwave frequencies in operation on this water vapor. Microwave frequencies from a mechanical mechanism. It's absolutely incredible. So we get this water vapor in here and what happens when you microwave water? So we get a high potential expansion rate of the water going through this valve and driving this piston. So we've got 2 different drive mechanisms working on this little motor. So the guy was a genius. There's no doubt about it, and this was a machine he gave up on. He went on to better and more higher things that we're only now beginning to get any kind of idea about. Any questions on this motor, or the water phenomenon, or the cavitation, the water hammer?
Can you fire it up?
No, it's not operational. It was about 2 years ago when I finally hit on the idea that it was water hammer. We did change some of the pipes because they were all split and broken, and some of the joints were broken. We soldered those up. We put new gaskets in it, and we put it in a bathtub, and we ran a little bit of water into it. And it was kind of phenomenal what happened. The thing, like it came alive. It just kind of, like it came alive. And but it didn't operate as we think it should operate. And we feel that's because of the timing mechanism in these valves. We don't understand those yet. So we really didn't know how to deal with those. And first and foremost is, this is an original priceless antique. We didn't want to mess with it very much. Just enough to see if my idea was correct about the water hammer, which we did prove and verify. So eventually, if we ever get any money, we're going to exactly duplicate this thing, and then we can play with that model all we want to. Yeah, you had a question?
Raise your hand if you have a question so I can get it on mic. All right, let's go ahead.
What would it cost to produce one of those machines?
I think machinist time is about between $30 and $60 an hour. It would take a lot of money. It would take several thousands of dollars, just machine work, to duplicate it. Now, another idea is, once we know the principles and how this thing works, we can design our own from scratch using electronic valves, so we get rid of the friction phenomena and all that kind of stuff. And I think we do understand it enough to design our own from scratch. And I do have some designs that I've worked with. I've got various devices that I've been working on the designs of that we may be able to build. Yes, sir.
Have you heard of the 300 mile an hour submarine? A gentleman, I believe it was in the 50s, built one as a one-man submarine. He crossed the Atlantic Ocean in about 24 hours, something like that. But I think he was using a turbine. But a turbine could be set up to use the cavitation principle. Each blade of the turbine would be making a cavitation.
Okay, that's a very good question. No, I haven't heard of that particular machine or that event. Using turbines is very interesting because the Tesla turbine, for instance, where you have the smooth discs, I have a model of it over on the workbench over there, on the book table. When it draws water in, if the velocity of that draw exceeds a certain point, the water cavitates, and it will cease to draw. Any pump will do that, can create that phenomenon. So you can only draw water in at a certain given velocity. However, I believe the same thing happens with air in jet engines. They can cavitate and they'll flame out and all that kind of stuff. Any fluid will do that. So certain designs, like the Schallberger material, seem to indicate that we can supersede, we can increase that ability, or we can push back that threshold of cavitation to a great extent, and thereby increase velocities and attain those things that you're referring to. I believe Keely was doing some of that work too. Although there is another way of how do you call it, propelling a craft or a mechanism that is not male-oriented. And we can get into that too. Remind me of that, and we'll cross into that. You have a question?
Dale, the opposing counterweights, what do they do? Is it perhaps that one motor goes for a while and then the other side goes, where those counterweights come up and down?
That's part of the questions we haven't answered in this particular design. We know that this weight maintains a pressure against this piston. This is what maintains the pressure within this cylinder, so that when this valve opens, it has that velocity to the water stream. This one over here maintains this piston closed. So when the water ejects against it, there's a certain resistance to the water stream. And I thought, well, why couldn't we use spring-loaded mechanism instead of these weights? And there is a different reaction to these weights coming down as opposed to a spring mechanism. And also in the 1880s, they didn't have the materials we got today, so he probably couldn't build a good spring like we can today. So there's many different questions. We don't have them all answered. You know, we've got the basic phenomena figured out, but why did he do this and do that and not the other thing? We can only conjecture. And the timing, each cylinder has its own timing, and how they work, plus the timing in the timing gears.
Comment on the spring. The acceleration from a spring is totally different from the acceleration of a released weight. So you wouldn't get an instantaneous switch or as rapid a switch. It would be a more gradual switch. So a spring would have a totally different mechanical phenomenology. And if you're opening and closing a valve, that's probably the best way.
Yeah, I agree with that. That's kind of what I came up with. I had built a model of this cylinder, and I used a spring because I didn't want to build all this mechanical stuff, just to prove that I could capture pressure with water hammer, and it did do that. So we can do those things. And I think if we had more engineering expertise working on this problem, we'd come up with all kinds of solutions to it.
Yeah, Dale, you said that you'd only find 2 books on cavitation.
Right.
Do you think the level of knowledge in physics right now is sufficient for you to be able to model the cavitation effect of this machine, say?
Yeah.
For example, you think that the theoretical development in physics, the level is high enough right now? All the concepts that we need to involve here present in physics sufficiently that we might be able to mathematically model this machine?
Easily.
You think so?
Easily, yeah. What goes on in here once you start to model it is real simple. It is echoes of shock waves and things like that. We know a lot about shock waves.
About shock waves, yeah.
And water hammer is a study of these shock waves within a given mechanism, water pipes. So that's where the breakdown occurs, is when you try and take the mathematical formula for water hammer and apply it to this engine. Well, it starts breaking down because those are designed for water tubing and piping and whatnot, and this isn't. So we've got to modify them to a certain degree to bring them into coincidence with what goes on here. But I do not think that what is happening here is beyond our current technology. Now, this negative attraction stuff is beyond our current technology. Not a perpetual motion machine. They called it that because they didn't know what it was or how it worked, or they didn't have any idea about it. They just call it perpetual motion. And my friend Victor Hansen, who is in the other room, he owns this machine. He bought it from the Franklin Institute for $1,000. Took him 8 years to get the money together to pay for it. He eventually got it and took it home. And he had it since the 40s. So he's had it for another 50 years. This motor was given to one of Keely's lawyers in the late 1800s. We assume it was given to him, or was part payment or whatever, we don't know exactly. A Mr. Housen. Later on, he donated this to the Franklin Institute in Philadelphia, and it sat in the Franklin Institute for 50 years. And they had a little sign on it that said it was a perpetual motion machine. Well, it was 3 or 4 years ago, I had a chance to look at it for the first time, and if any of your engineers and you look at this thing, you say it is absolutely bizarre. There's no way this thing can work. Because in conventional male-oriented physics, where we put in energy, we got to hit it with something, This makes no sense because it doesn't operate with that philosophy. It operates with the female forces of implosion. So the thing kind of operates this thing a little crank, and it would create a vacuum, and the water would draw itself through the machine. Now, one interesting concept is the water formed a part of the mechanism. That's not normal physics. That's not normal engineering. We don't normally do that, where the water is actually part of the motion of the machine. So this thing is kind of like a holistic machine. It's not a machine operating on the water or the water operating on the machine. It's the water and the machine operating backwards. And when you look at it a little bit and you say, well, this thing operates backwards, and then all of a sudden your mind just gets all clouded and confused because you're not used to thinking in those terms. But after a while, it gets kind of simple. and this is brilliant. If Keely did anything, he was a brilliant machinist and a brilliant mechanic. He just had a cleverness of making things. Water would come in through this orifice. Once he got the thing primed with water in the system, he could just kind of crank